Hello, math friends. Today we're going to solve 1 and 2 inequalities. When I solve inequalities, I try and think a lot about the rules that I use for solving equations. So when I solve an equation, I'm trying to get an x, or a variable, all by itself on one side of my equation. And usually when I write my answer for inequalities, I want that variable to be on the left-hand side. To do that, I'm going to use my inverse operation. So I've multiplied by -5, so using my inverse operations like I would with equations, I divide by -5. And I end up with x is greater than -8. So there's my solution to my inequality. So that tells me this inequality has a whole bunch of answers that should fit for this situation. So I maybe could fill in any number that's bigger than -8. So maybe I fill in 1. 1's bigger than -8. So if I fill in 1, what's -5 times 1? -5 times 1 is -5. So is this true? Is -5 greater than 40? Oh. -5 is not greater than 40. That is not good. This is the one spot where it's different than solving equations, because when we multiply or divide by a negative, when you multiply or divide by a negative, you flip your sign. Woo! Here is the big old rule. You gotta know it. When you multiply or divide by a negative using your inverse operations here, you are going to have to flip your sign to keep your inequality true. So instead, when I did this divide by -5, instead of having a greater than sign, I should be flipping it to x is anything less than -8. And this is my solution to my inequality. I can fill any number smaller than -8 in, and it should work. Let's try it. What if I use -10? -10 is smaller than -8, just one of the many solutions that would work. I fill it in. I'm going to erase this so it's a little easier to see. If I fill in now my -5 times -10, well, a negative times a negative is a positive, so that's going to give me 50. 50 is greater than 40. It works! Woo! This is the rule you have to know. Now, you don't always have to use that rule. Sometimes you don't multiply or divide by any negatives at all. Let's take a look at this one. So again, I'm still going to try to get my variable all by itself. And to do that, I'm going to have to move my numbers. So I have -10. I'm going to use my inverse operation of addition, and I'm going to add 10 to each side of my inequality. No multiplying or dividing by negatives there. -12 plus 10 gives me a -2 is greater than x divided by 3. Now I have divide by 3, positive number. I multiply by 3. I leave my inequality sign exactly how it is. 3 times -2 is -6. So -6 is greater than x. My solution to my inequality is that, hey, I should be able to have anything that's less than -6. And like I said earlier, maybe the better way to write it would be x. Keep it still pointing at the x, but writing the x on the left-hand side is -6. Either way, you could write it either way, but they like it in the math world better if you write it like this, variable on the left. So I picked something smaller than -6 to fill in. Let's pick -8. Ooh, I don't like -8 because it doesn't divide nice with a 3. Let's instead pick, how about -12? That's smaller than -6 too. And it'll be way easier to check. So I do -12 divided by 3 would give me -4. -4 minus 10, I'm going to stop, chop it. -4 plus -10 is a -14. Is -12 greater than -14? Yes, it is! I had no multiplying or dividing by negative, so I didn't have to flip my sign. However, I did go ahead and make it so that my variable was on my left when I wrote my solution. Isn't this fun stuff? Oh, you've been learning solving equation stuff forever, and now you just have that one little thing that you got to super remember, that when you multiply or divide by a negative, you flip your inequality sign. Otherwise, all former rules apply. Super sweet. Go rock the inequalities, friends.